All right, so here's a stoichiometry question we're going to go over here, and it says this. Given the reaction NaCl plus CaO produces CaCl2 plus Na2O, what is my theoretical yield of sodium oxide? So this is the sodium oxide right here. If I start with 20 grams of calcium oxide, and here's calcium oxide, okay? So remember, theoretical yield is what, in theory, you should produce if every part of your reactant, if all the reactants, every little bit of it reacts completely, 100%, how much should you get? And we're going to calculate that using the balanced chemical equation. So I got to first check to see if this equation is balanced. It doesn't look balanced to me, and you should notice right away that I have, there's two Cl's here, I only have one Cl over here. So I'm going to put a 2 right here. And I have two NAs over here, and I only have one over here, but now I have 2. So this is now balanced. 2 to 1 to 1 to 1. I have one oxygen, one calcium, one calcium. We're good to go now. So this is classic stoichiometry. So I've got 20 grams of calcium oxide. Okay, so I'm going to write calcium oxide here, and I'm going to write 20 grams right here. And I need to find out what's my theoretical yield of Na2O. So here's Na2O. And these are 1 to 1 ratios. That's perfect. It's going to be easy. So first thing you do, you convert all mass to moles. Because remember, these numbers right here are molar ratios of these substances. They are not mass ratios. They are molar ratios. So 1 to 1 means 1 mole should produce 1 mole. 2 moles should produce 2 moles. 4 moles of CaO should produce 4 moles of Na2O. You see, 1 to 1. Moles. So 20 grams, get your periodic table out. Get your calculator out. And what you want to do is you want to find the moles of CaO. So I'm going to take 20 grams and I'm going to divide by the grams per mole of CaO. So calcium is 40.078. And I've got one of those, and I've got one oxygen. Oxygen is 15.9994. So I'm going to find the number of moles. Okay? 20 divided by, and I'm going to put my brackets there, 40.78 plus 15.9994. Okay? And that gives me 0.3522 moles. So that's the number of moles that I actually have. 20 grams of calcium oxide actually equals 0.352 moles. 0.35224 moles of CaO. Okay? That's what my calculations have told me here. All right, so now this is what we have, and I'm trying to find out how much sodium oxide I would produce, or what I should produce, the theoretical yield. So we look at our balanced equation, and again, it's a 1 to 1. So what does that mean? That means I take this number of moles and I times 1 over 1 to get my number of moles of Na2O, which is going to be pretty easy, right? So it's the exact same number of moles. Remember, 1 to 1 means 0.352 to 0.352. Easy, totally easy. So now that's step 3 really. Here's step 1, finding the moles. Here's step 2, converting moles to moles. And now step 3 is, let's convert this now to grams. So what is my theoretical yield? That's they're assuming that you're going to give the yield in grams, especially if the original reactant was grams. So the yield should be grams, okay? Grams. All right, so how do I do that? Well, I take this number of moles right here, and I multiply by the grams per mole of Na2O. So what's that? Well, get on my periodic table. I'm going to multiply this number right here by, so sodium is 22.98977. Oh, that's times 2, isn't it? Look at Na2. So I got to do this times 2. And I have to add 1 oxygen, 15.9994. Okay. Awesome. Get out my calculator here. And I've got the number of moles already on my calculator, so I'm just going to hit times. I'm going to use brackets. 2 times, I'll use another set of brackets there for 22.98977. Okay, plus, bracket, plus 15.9994. And I think I should have 2 closed brackets there. Okay, so if you have 2 left brackets, you should have 1, 2 right brackets. Oh, good thing I double checked that. Okay. So that's multiplied by the grams per mole, and enter, I get 21.83. 21.83 grams, 21.83 grams of Na2 would be your theoretical yield. Now, if this is for sig figs, that's only 1 sig fig, so you could say, you have to round that to 20 grams for sig figs. But leave both of those answers, okay, if you're wondering. Show me all your decimals, and then you can round to sig figs. I'll never fault you for rounding to sig figs. But in this question, I don't think that they really intended that to be a very precise measurement. So they're not worried about sig figs there. Okay, so that's that. That's question number 7. Someone asked about that. So let me know. Does that help? Any questions about that?